This is Precalculus, lesson 9.2. So now we're going to add some more identities and work through some proofs. All right, we're going to add the cofunction identities and the sum and the different. All right, so I want us to look at the sum and the different. So if for the sign, it's u plus v, if it's positive, then I'm adding these. If it's negative, then I'm subtracting those. So the sign on the top here, those signs go together, the sign on the bottom goes together. For the cosine, if I'm adding here, I'm subtracting. If I'm subtracting, I'm adding. Same with the tan. If they're adding here, I'm adding numerator, subtracting denominator. If they're subtracting, I'm subtracting in the numerator, I'm adding in the denominator. So the top signs go together and the bottom signs go together. And it's dictated by this side right here, which you will see in just a minute, all right? So there's only one example we're not gonna work through, and that's the one that looks to calculus, the difference quotient, all right? We're not going to work through that one. All right, so now we're going to have the sum and difference formulas, which your textbook calls them addition and subtraction identities. They are on, well, the sine and the cosine ones are on page 582, the bottom page 582, and then the tangent is just one page. Flip one page over and you'll see it, all right? So we're going to begin why we might want to use addition or subtraction identities. And the reason we potentially would want to use the addition or subtraction identities is if we are given a radian measurement such that it's not on the unit circle, but we can add two radian measures or subtract two radian measurements that are in fact on the unit circle, all right? So that we can, use our values on the unit circle. All right, so let's look at the first one. The sine of 5 pi over 12. All right, are there two values on the unit circle that I can add? I can split this into two such that it's the sine of the sum of those two radian measurements. Well, I know that if I split it 3 and 2, if I split that 5, 3 and 2, I knew that they were both factors of 12, so that I could then further, so this is really that added, and I knew that I could further simplify that to be pi over 4 plus pi over 6. These are in fact on the unit circle. Now I can look, and because it's plus, what does that equal? This is your u value, this is your v, or your first one, second one. So it's sine of this times cosine of that, plus cosine of this times sine of that. All right, you're just following your formulas. All right, when it's plus, I know it's plus. For sine, it's the opposite. For cosine, it's just the opposite. So it's the sine of pi over 4 times the cosine of pi over 6, the first one, times the second one. Then I swap them, plus the cosine pi over 4 times the sine pi over 6, and I can calculate that. So that I can calculate what this is using exactness, right? All right, first of all, I'm noting we're in the first quadrant for all of them. The sine of pi over 4 is square root of 2 over 2. All right, for the cosine, that's pi over 6. So that, if this is my unit circle, it's that first radian measurement off of the x-axis. So the cosine starts at 1 and goes down. So it's 1 square root of 3 over 2. So it's square root of 3 over 2 because it counts down. Because it's 1 square root of 3 over 2, square root of 2 over 2, 1/2. Okay? Cosine and sine are exactly the same at pi over 4. Now the sine is going to be 1/2 because the sine starts at 0 and counts up. So it's 0, 1, so it's 1/2. All right, so what are we left with? Square root of 6 over 4 plus square root of 2 over 4. And can anything that they went and further factored it, okay? They wrote this number over your one common denominator. I don't want to get too low here. All right, so then they wrote square root of 6 plus square root of 2 over 4. They pulled out a square root of 2. Square root of 2 times square root of 3 plus 1 all over 4. And I believe that this was their answer for the sine. All right, cosine would be the same, except that the plus is going to be minus, and it's all cosine and it's all sine. All right, so I'd find that the exact same way. I'll just erase all of this. Use those same measurements, right? Those same ratios. So if this were instead cosine, right? With your cosine plus here is minus. And your first two terms are cosine, your second two terms are sine. So it's cosine pi over 4 times cosine pi over 6, sine pi over 4 times cosine pi over 6. Again, using those ratios from the unit circle, pi over 6 is square root of 3 over 2. Sine, I don't know why I hit equal. Square root 2 over 2. And I wrote cosine here, I meant sine. And that is 1/2. Writing everything over 4. Factoring out that square root of 2, it's square root of 3 minus 1. All right. You hanging with me so far? All right, look at example 2. We'll do a minus for the sine. And they already give us the angles. What? It's pi minus 1. So sine of pi minus y. So if it's minus for sine, it's minus. The cosine is just the opposite, right? And then it's the sine of the first one times the cosine of the second one. So it's the sine of pi times the cosine of y. Now you swap them. Then it's the cosine of pi times the sine of y. All right, so you're just swapping those for the sine. For the cosine, the signs are the opposite, and it's cosine, cosine, sine, sine. All right. All right, at pi, that's on the unit circle, right? That's right here. Your cosine is -1. Your sine is 0 because the cosine relates to that x value, the sine relates to that y value. All right, so the sine there is 0 times the cosine y minus negative 1 times the sine of y. Well, that's 0. So it just equals the sine of y, whatever that value is. All right? Now, look at number 3. Number 3, now we have an equation. For number 3, I look and I say that left-hand side, is pretty simplified. So I'm not going to work on the right-hand side. I'm going to work on the left-hand side because I see the sum of 2 angles. All right? So I see the cosine x times the cosine y equals 1/2 times cosine x plus y, that's my sum, plus cosine x minus y, that's my difference. So I'm going to work with these two and substitute. All right, I'm going to leave that left-hand side alone. We'll leave it cosine x times cosine y. I'm going to leave the 1/2 alone. For this, I'm going to substitute in the identity. And for the cosine, if it's plus, it's minus. So it's cosine x times cosine y minus sine x sine y. And when it's minus, it's plus. All right, so it's this whole thing, this first whole term, plus this second whole term. All right, but because it's a plus, I don't have to open a parentheses. If it were minus, I'd open the parentheses and I would distribute that negative to every term in what I'm about to write. But it's not. All right, so it's the cosine x, cosine y minus is plus sine x sine y. All right, so notice what happens. Our signs eliminate. These are like terms, so I'm going to combine my like terms. Cosine x, cosine y is 1/2 times. I add their coefficients, it's just 1 and 1, so it's 2 times cosine x, cosine y. Now I multiply. 1/2 of 2 is 1, so these two are, in fact, equivalent, and we just proved it. All right? Easier said than done, right? I know it's hard. We're not going to do example 4. All right, so